Hey everyone, what if I told you that the most valuable thing a programmer creates isn't actually code? Today, we're diving into a pretty radical idea from OpenAI's Sean Grove that could totally change how we think about building software and maybe even who gets to build it. So first up, let's talk about the programmer's real value. We're going to challenge a core assumption here about what we're all getting paid to do. So let me just ask you straight up, what is a programmer's most valuable professional creation? I mean, the gut reaction, the obvious answer for all of us is the code, right? But what if that's not just wrong, but fundamentally misses the point? Well, the reality is the code itself, the part that gets compiled and run, is maybe 20% of the real value. The other 80%, the massive chunk of the pie, is what you could call structured communication. It's all the talking to users, the debating, the planning, the distilling of requirements, all the hard work to make sure you're building the right thing. The code is really just the final artifact of that whole process. And you can see this in action with the rise of what people are calling vibe coding with AI. Think about it. When you're using an AI assistant, you don't start with perfect, clean syntax. You start by just describing what you want. You communicate the goal, the vibe, and the AI generates the code. It just goes to show that our natural instinct is to communicate our intent first. The code is secondary. But this leads to a really strange, almost backward habit we've all fallen into. For decades, the rule has been you keep the source code and you throw away the compiled binary. But with AI, we're doing the complete opposite. We're carefully saving the code the AI generates, and we're just throwing away the prompt, the actual source of our intent. Sean Grove puts it perfectly. He says it's like you shred the source, and then you very carefully version control the binary. It's absurd when you think about it like that, right? We're throwing away the most valuable part, that clear human expression of the original goal. Okay, so if our prompts and our intent are the real source code, what should we be focusing on? Well, the answer is a more formal, more robust version of that intent. We're talking about the specification. This is the new code. So what is a specification? Simple. It's a written document that captures the full intent, the values, the goals, the constraints, everything about a project. It becomes the single source of truth that aligns not only the AI that's going to generate the code, but just as importantly, all the humans working on the project.
See, code is just a lossy projection of a good specification. Think about it. It's like trying to decompile a binary. Sure, you can get something that works, but you lose all the comments, the variable names, the original structure, the intent. A good spec preserves all of that nuance right from the very beginning.
And this is where the real power comes in. A single, well-written spec is incredibly versatile. From that one document, you can generate your TypeScript and your Rust and your user documentation and your tutorials and, hey, even your marketing blog posts. The spec becomes the true source for absolutely everything. Now, this isn't just some abstract theory. Let's look at a real-world example of this in practice right now, the OpenAI Model Spec. This is the document that governs the behavior of models like GPT-4. And what does this new code actually look like? Get this, it's just a collection of markdown files in a folder. That's it. Because it's written in plain English, it's totally human readable. It's version controlled in Get, and this is huge. It means non-technical experts from legal, policy, and safety can all contribute. They can make commits right alongside the engineers. It's a universal language for human alignment. But here's the really clever part. It's executable. Every single rule or clause in that specification has a unique ID, something like SY73. And that ID links directly to another file that's just packed with challenging prompts, specifically designed to test if the model is actually following that one rule. The spec literally contains its own unit tests. And this became super important not long ago. You might remember an update that made GPT-4o act weirdly sycophantic, overly flattering and agreeable. People noticed, and it started to erode trust. Was this intentional? Well, the OpenAI team could point directly to the public model spec, which already had a rule explicitly forbidding that exact behavior. It was proof that this was a bug, not a new policy, because it violated the agreed-upon specification. In that moment of confusion, the specification acted as a trust anchor. It was this public, verifiable document that clearly communicated the intended behavior, which allowed the team to align with its users and transparently say, yep, that's a bug. We're fixing it. So how do we make these specifications executable? I mean, how do you get a machine to not just read these rules, but to actually embody them in its behavior? The technique is called deliberative alignment. The short version is this. You have your model generate a response, then a second AI, a greater model, scores that response based on how well it follows the rules in the spec. And then that score is used to reinforce and retrain the original model. You're basically teaching it the spec over and over until it gets it right. And what this does is so much more efficient. Instead of having to cram all the rules into a prompt's context window every single time, this process bakes the policy directly into the model's weights. It literally becomes part of its muscle memory, making it deeply aligned by defaults. Now let's zoom out a bit, because this idea of writing down specifications to align an actor with a goal, this isn't new at all. In fact, you could argue it's one of the most fundamental human activities there is. Think about it. A programmer writes a code spec to align silicone. A product manager writes a product spec to align teams of people. A lawmaker writes a legal spec, or a law, to align a whole society of humans. We are all programmers, in a way. We're all writing specifications to shape the behavior of complex systems. And what's the grandest example of all? A national constitution. It's a specification for a country, and it has a versioning system. We call them amendments. And it has unit tests. We call that judicial precedent, which clarifies all the ambiguous clauses. It's the exact same pattern, just on a massive societal scale. So what does this all mean? It means the definition of a programmer is getting a lot bigger. In this new world, anyone who can clearly write down their intent in a prompt is a programmer. The new scarce skill, the really valuable thing, isn't writing code. It's writing specifications that fully and clearly capture human goals and values. So how can you start using this today? It's actually pretty simple. The next time you start an AI feature, don't write a line of code. Start by writing down the spec in plain English. Then debate that spec with your team until it is crystal clear. And finally, make it executable. Use that document as the benchmark to test whether your model's output is actually doing what you want it to. And that leaves us with one final thought to chew on. What does the IDE of the future even look like? Maybe it's less of an integrated development environment and more of an integrated thought clarifier, a tool designed simply to help us refine our intentions for each other and for our new AI partners. Thanks for tuning in.